All right, hey folks, this is going to be a video on the tangent and the cotangent parents. I actually tend to like doing the cotangent graph first, the cotangent parent first. So just go ahead and go down here and then we'll come back and do the tangent parent. Now we know, according to our quotient identities, that cotangent of x is the same thing as cosine of x divided by the sine of x. And because we have a fraction, just like in secant and cosecant, because we have a fraction, then we have the opportunity for some vertical asymptotes wherever the sine of x is equal to 0. So sine of x is going to equal 0 at 0, as well as at pi and at 2 pi. Okay, so we can go ahead then and we can get our 4 equal intervals. And if we just go with the normal unit circle, we'll have our first quadrant, pi over 2, pi, 3 pi over 2, third quadrant, and 2 pi for the fourth quadrant. And I'll have at 0 and at pi are going to be asymptotes. But if you think about it, 0 and 2 pi are the same position, so 2 pi is also going to have an asymptote. Now at pi over 2, that is going to be 0 because that's going to be 0 over 1, which is 0, so that's going to be an x-intercept. And at 3 pi over 2, it would be 0 over negative 1, so another x-intercept. All right, so pi over 4, if you get the cotangent at pi over 4, that's going to be the same thing as 1. And at 3 pi over 4, it'll be negative 1. All right, so what that means then is that pi over 4, which is right here in the middle of 0 and pi over 2, at pi over 4, I'm going to be graphing somewhere up here at 1. At 3 pi over 4, I'm going to be graphing down at negative 1. Now I'm just going to go ahead and give you the shape of your cotangent graph. Now you notice the first quadrant, the first piece that I drew, looks a little bit like half of a parabola. But the second piece I drew, remember that we're going to be working with negative 1, so it's got to be down here below somewhere. That's going to look something like this. Also looks like half of a parabola, just not matching up with the first half. All right, if I were to continue looking at the unit circle and to look in third quadrant, what is the cotangent at 5 pi over 4, you would find that it is once again 1. And then if you were to look at the cotangent at 7 pi over 4, smack dab in the middle of the fourth quadrant, you would find that it's negative 1. All right, so you'll notice that my asymptotes are at the beginning, the middle, and the ending. You'll notice that the x-intercepts are at the quarters. And you'll also notice that this is a decreasing function. Now, before I go and work on tangent, let's go ahead and get these answers to these questions. My range is going to be all real numbers. My x-intercepts start at pi over 2, and then I have another x-intercept every pi from there. So after 1 pi, after 2 pi, after 3 pi, every whole pi, I'm going to have another x-intercept. Now, here's the tricky part. What is the period? How far does it go before it starts repeating itself? And I think you'll notice here that one period is between the first two asymptotes, and then a second period occurs next. So the period is going to be just pi. This is the first time we've had a period that isn't 2 pi. So the period is pi. Once again, just like in secants and cosecants, there are no maxes or mins, so we have no amplitude. All right, and you can see here I've got a calculator version of cotangent as well as a textbook version of cotangent. All right, let's go backwards then and do our tangent graph. Tangent we know is equal to sine over cosine. So my asymptotes then are going to occur wherever cosine is equal to 0. Well, cosine is going to be equal to 0 at pi over 2. Now we're not going to go left, but also at negative pi over 2. And at 3 pi over 2. So let's go ahead and get our 4 equal intervals and put our unit circle values on there. So pi over 2, pi, 3 pi over 2, and 2 pi. And so if you're looking at your unit circle, you see that at pi over 2, cosine is 0. So the whole entire tangent then is undefined. And at 3 pi over 2, the same thing occurs. All right, now let's look at some other coordinates. Still looking at your unit circle. What is the tangent at 0? Well, sine over cosine is going to equal 0 over 1. So we'll have an x-intercept at 0. At pi, and I don't have any more places to fill in, but at pi, my tangent graph, sine divided by cosine, is going to be 0 divided by negative 1. So once again, 0. And at 2 pi, 0 divided by 1, which is 0. Just like I did before, if you think about your pi over 4 positions, pi over 4 in the first quadrant, the tangent is going to equal 1. But in the second quadrant, it's equal to negative 1. In the third quadrant, it's equal to positive 1. And in the fourth quadrant, negative 1. So then my tangent function, using my points and using my asymptotes, this is how the first piece of my tangent function is going to be. Second piece is going to be like this. And the third piece, I start repeating. In fact, let me do that in a different color so you can see it. I'm starting to repeat. The exact same values here are what I had to begin with, starting on the x-axis and going up and to the right towards that vertical asymptote. So you can still see that I have 2 periods. My first period goes from 0 to pi, and then I start repeating myself at pi, and it continues to 2 pi. So I have 2 periods drawn. And I said these, but I didn't uncover them. Notice that my tangent graph is increasing. This time the asymptotes occur at the quarters, and the x-intercepts occur at the beginning, middle, and ending. So that's how the parent graph looks. My range is going to be all real numbers. My x-intercepts, notice that my first one is at 0, and the next time I have another one, it's pi down the road. So that's why you have 0 plus or minus whole pi's. The period, once again, is pi. No max or min values, so I have no amplitudes.